Okay, thank you.
Good morning, all. This camera is visible to.
Yes,
Okay.
sir.
Yes, sir.
Just pin to Pradeep Gaikwad sir account. I hope I'm audible and the screen is visible also. Okay.
Yes, sir.
So in the last session, we discussed about complex algebra method and its basic part. So today we have to use this method for kinematic analysis of different mechanisms. So the mechanisms that we have,
सर ब्लर है.
it's blur. You check it please now because I just connected to Wi-Fi also. Check it now. See, now I just discussed these are the basics of complex algebra and we've seen how to find out velocity, acceleration of any link by using complex algebra method, its general form. We use this for finding displacement, velocity and acceleration of mechanism. Before going to start its application for finding velocity acceleration, we need to understand one basic concept, a very important concept, that is nothing but a loop closure equation. Now what this equation is, we'll take with example in online examination. As your examination may be online, most maybe online, we don't know about how the exam pattern is. But generally, if it is online examination, then on this topic, maybe questions are there. I'm saying if onlines are there are more chances of getting questions on this topic. And of course, this topic is required for kinematic analysis, or I'm saying to start kinematic analysis by using complex algebra method, we need loop closure equation. So we need to understand this topic first, then we'll see how to apply this for kinematic analysis. So let's say consider one 4-bar mechanism like this. I consider one 4-bar mechanism, and with this one is a fixed link AB, or you can say this one is AB, C, and this one is D. So AD is a fixed link. AB, BC, and CD are 3 other links. Now tell me, if I want to find out position vectors of these links, how I can write? Let's say first find out absolute position vectors. Then what is its vectors? Yes, please tell me. How I can show its position vectors? With reference to the origin, we have to define. So absolute position vectors of these links, let's say at point A, B, C, D are given by, I'm saying absolute position vectors. There are two, absolute and relative. Absolute means with respect to fixed reference. So when I'm finding position vector of A with respect to fixed reference, let's say it is vector A. I'm saying absolute position vector A. When I'm writing B, it must be with respect to this reference, that is B. Then for C it is vector C, and for D it is vector D. So A, B, C, D are the absolute position vectors of A, B, C, and D. Now the relative position vectors are given by, so to find relative position vectors, how we can write relative position vectors for link AB? It is nothing but vector AB. So vector AB is relative position vector of link AB. Similarly, when I'm writing BC, BC is relative position vector of this link BC, or I can say it is position vector of B with respect to A. This one is position vector of C with respect to B. So AB is relative position vector of B with respect to A. I'm saying relative, it is not absolute now. A, B, C, D are the absolute position vectors, while vector AB is a relative position vector of B with respect to A. This one is C with respect to B. And if I'm going further, it is CD is position vector of, or I'm saying relative position vector of D with respect to C. Further, if I write DA, it is relative position vector of A with respect to D. Now, how to write this? I can write these vectors as, we know that this vector B minus vector A. So relative vector can be write like this. When I am saying it is relative position vector of B with respect to A, then it is B minus A. If it is same, I'm saying relative position vector of C with respect to B, then it is of course C bar minus B bar. Similarly, here it is D bar minus C bar. It is equal to A bar minus D bar. Now, why I'm discussing this relative and absolute position vectors? Because I want to discuss a loop closure equation. Now, if I add this all relative position vectors in this mechanism, that is in a 4-bar mechanism, I can write it as vector AB plus BC. When I say BC, consider it as vector only. Then it is CD, vector CD, and vector DA. If you observe how I write this equation, how I write these vectors, I write in a particular order. Means I started with A, so A to B is vector AB, B to C is vector BC, C to D is vector CD, and then D to A is vector DA. And if I add this all vectors, it must be equal to 0. Now what is this? This equation we obtain by adding all these vectors, I'm saying relative position vectors in a order, and which is equal to 0 is nothing but a loop closure equation. So I just told you what is loop closure equation with this example. I repeat what I did. I just consider one mechanism, let's say ABCD. For this mechanism, I find out absolute position vectors of A, B, C, and D. Then with respect to this absolute position vectors, I find out relative position vectors for link AB, BC, CD, and DA. Now if I add these vectors, it must be equal to 0. Now who told you this must be equal to 0? It is nothing but loop closure equation. Now what is loop closure equation basically? The loop closure equation is the sum of relative position vectors. So sum of the relative position vectors. Sum means addition. Addition of these relative position vectors for the links forming a closed loop. Those links in a mechanism forming a closed loop in a given mechanism and also taken in a order. Means if I add these links, if I add relative position vectors of these links in a mechanism in a order, in a sequence, then it must be equal to 0. So if there is one mechanism having different links, and if I find out relative position vector of them, if I add them in a sequence in a order, then their sum must be equal to 0. This is what your loop closure equation is. And according to that, I add this relative position vectors in a order. What I'm saying in a order, because vector AD and vector DA is different. Vector AB and vector BA is different. If I write BA, that is vector BA, it is equal to S. What is the difference here between AB and BA?
A minus B.
So it is A minus B. So I can't write both are same. So what I said, if I consider links in a mechanism forming a closed loop, of course it must form a loop. And if I add them means I add relative position vectors taken in order, or you can say taken by order, then their sum must be equal to 0. So you can observe here, I started with vector AB, then BC, then CD, and then DA. I have not written AD, I written DA, CD, BC, and AB. So AB plus BC plus CD plus DA, here it must be equal to 0. This is your loop closure equation. So I repeat, the sum of the relative position vectors, I think there is no need to write statement here, but I'm just orally telling you, you can listen. Sum of the relative position vectors for the links forming a closed loop in a mechanism taken by order is always equal to 0. This is known as a loop closure equation. Now remember, loop closure equation gives relative position vectors of different links forming a closed loop in a mechanism. And the links forming the closed loop in a mechanism are rigid. You observe this? These links are rigid. Rigid means the joints of the links always remains a fixed distance or having a fixed distance from the other. Means A and B distance will not change. Distance between B and C will not change. C and D will not change, or A and D will not change. So they are rigid means I'm saying the distance between the joints will always remain same. Therefore, even loop changes its position, the magnitude of relative position vectors do not change with respect to time. What I'm saying is very important conclusion. Even though this loop or this mechanism changes its position, let's say it is moving from AB to AB dash. So there is some other position of this mechanism. It moving from A, B dash, B dash, I'm saying A, B dash, C dash, and D. So some different position. At that position also, this magnitude of relative position vectors will not change with respect to time or with respect to change in position. That is what about loop closure equation. Now I hope you get idea what loop closure equation is. Yes or no? What is loop closure equation? How to write it? Anyone please? Yes. Is it clear or not?
Yes, sir.
Yes or no? At least reply. Otherwise, if not, then we'll repeat. But I think those are concentrating, they will get this. Clear, okay. Okay, yes.
Done, sir.
Okay. Now tell me, I written this loop closure equation for a 4-bar mechanism. And I told you, applying loop closure equation or using loop closure equation is nothing but first step for a kinematic analysis by using a complex algebra method. So we have to use this loop closure equation first, then we proceed further. Actually, what you can see, vector AD is nothing but what position vector. AB, BC, CD, and AD. What it gives you, this loop closure equation gives you relative, or I'm saying relation between different position vectors of a same mechanism. So we get relation between AB, BC, CD, and AD like that. Once you know position vectors, I can differentiate this with respect to time to get velocity, further differentiate to get acceleration like this. So first step is nothing but applying loop closure equation in that mechanism. So let's consider some other mechanism like this. Again, I consider coordinate system here with respect to this origin O having 0, 0 coordinates. And let's say consider now here slider mechanism. Assume that there is no offset between the path of slider and the crank center. And the points are A, B, and C. Now tell me how I can write loop closure equation here. Tell me loop closure equation for this case. Screen is clear for all? Because someone
Yes.
is saying screen is not proper viewing. Shreyansha, I think it's a network
Sir,
problem
it
for
is quite blur.
others.
Yes, sir.
It's blur or clear or not? Means for others it is same.
Sir, clear है.
See, it's a network problem from your side only. Please check.
Okay, sir.
Yeah, sometimes it may blur due to network problem only. Because from my side, there is no problem. If there is problem, it is from your side. So please take care of that. Okay. Those are having blur, you please check your network. That's what I'm saying. Okay, now that's not an issue. I hope you get idea. Tell me this one. How to write loop closure equation for this mechanism? Gopal is saying AB plus BC plus CA. Of course, it is right. Because see, when I say loop closure closure equation, I consider this loop AB plus BC plus CA. So the first relative portion vector is, I'm not going to discuss absolute now because absolute is just basic. So vector AB plus vector BC plus vector CA. We have to consider a closed loop and in a order. I can write AB plus BC plus AC. So that is wrong. But if I write AB plus BC plus C, that is right. So go in a order and just add your relative position vectors in a particular order. So I'm writing here vector AB plus vector BC plus, yes, vector CA is equal to 0. You can verify whether it is 0 or not. You can check whether it is 0 or not. Let's try here. What is my first one? AB. So I'm writing AB is nothing but what? What is AB, please? Yes. How to write AB? Vector AB?
B minus A.
B minus A.
So it is B bar minus A bar. Now plus, yes, vector BC. BC, how I write? C bar minus B bar plus CA. That is A bar minus C bar. Now check it. This B bar plus minus plus minus plus minus. It must be equal to 0. That's what. So if you taken in order, it must be equal to 0. So likewise, you can apply a loop closure equation. That is your first step in kinematic analysis by complex algebra. Okay. Now let's apply this for one more mechanism. Now same mechanism I'm considering, that is slider crank only, but the change is here. Let's say here it is crank, and this is path of the, I'm saying the crank center. Here it is line of crank center, and connecting rod I consider here. So there is some offset between the path, I'm saying center of the crank and the center of the path of the slider. Let's say that point is, some distance is there, and these points are A, B, C. Now tell me how to write loop closure equation here in this case. How to write loop closure equation here? What is your loop closure equation? Yes, please. This is your origin, we can say. I request you, whenever listening lectures, try to make notes, or at least sit with pen and pencil, something, paper and pen, so that you can try it, you can answer, it will be interactive. Yes, please, anyone? Loop closure equation here. The last case it was CA, but now we can't write CA directly. What to do? Yes, anyone, please? That can't be a loop. Okay, good. Any other? Now see, whenever there is no loop, we need to make that loop. So what I do in this case, I'll just take one more point here, which is not a part of this mechanism actually. But I'll take point D, and now I'll write loop closure equation. If I add one point D, how I can write? See here, it is vector AB plus vector BC plus, even though D point is not part of mechanism, but I write it as CD plus DA, and it is equal to 0. Clear or not? So if there is no loop, you have to form that proper loop. So I can write like this, because this is D is additional point, and I can use it just to write this loop closure equation. Of course, its absolute position vectors are vector A here, then B, then D and C. These are A, vector B, vector D, and vector C. And the loop closure equation will be like this. Okay. So likewise, we have to apply, we have to write a loop closure equation for different mechanisms. Now we'll see how to use this for solving a numericals. Because in the last session we discussed just basics of complex algebra, how complex form is used, how to write that. Let's start with an example. I hope you have noted down this numerical. I'll write in brief. The first numerical on complex algebra. So numerical on complex algebra. We have to solve two numericals at least today, or one will solve, and I'll just give one for you. Okay, so it is in a slider crank mechanism. In a slider crank mechanism, the crank radius is 100 mm. Now tell me notations, please. Crank radius is 100 mm means you have to write separately. We say R is nothing but crank radius and L is crank length. So R is given to you. Crank radius is 100 mm. You can write given data. Crank radius is 100 mm and length of connecting rod is 500 mm and length of connecting rod is 500 mm. I'm just writing this numerical. You can copy this. Just wait for a minute. Huh? Okay, so this is your numerical given. Now all of you tell me given data from this numerical. What is given and what to find out? The statement is in front of you. Yes.
L is given, R is given, omega is given,
So I'm
alpha is
reading
given.
one by one. See, okay, I'm reading one by one. In a slider crank mechanism, crank radius is 100 mm. So what is it? Yes, in given data, crank radius means we take notation R. R is equal to 100 mm. Next, length of connecting rod is 500 mm. Notation is L. As we use R and L for crank radius and length of connecting rod, it is 500. Next, rotating counterclockwise direction at angular velocity of 15 radian per second. What is this?
Omega.
Yes.
Omega.
It is angular velocity of connecting rod. Sorry, crank. Is given crank is rotating, no? Yes. So it is omega of 2. I am saying as 1, 2, 3 other notations will take. Omega 2 is equal to 15 radian per seconds, and direction also given. How it rotates? Counterclockwise. So it will be in this direction. Omega 2 is known to you. And angular velocity is given, angular acceleration of 115 radian per second square. So alpha is given. It is for, so alpha 2 is known to you, is equal to 115 radian per second square. The direction is not mentioned. Find, what to find out then? Acceleration of piston. So I'm writing, first we have to find out acceleration of piston and angular acceleration of connecting rod. So it is nothing but alpha of connecting rod means alpha of C I'm saying, or you can say alpha of 3. When the crank is 60 degree from IDC, so position is given to you, theta is equal to 60 degree from IDC. So if I want to draw diagram, the diagram will be like this. We can draw anywhere. That means I can draw like this also. This is your crank. And from IDC, its angle how much given? 60 degree. So this is your position somewhere here. This will be slider. Like this you can draw, or if you want you can draw like this also. Here you can take center. From IDC it is given. So IDC means on this side, theta is 60 degree. And this is your crank. So you can draw anyway. This is your R, this is your L, R, L, and we need to find out next. So it is essential to draw diagram. So we'll get better idea. Now here, let's say I use this diagram. Theta 2 is known to you. Theta 2 is nothing but 60. And if you want to find theta 3 is from this reference position. So first coordinate. This is your theta 3. The fourth link is slider. The slider, there is no need of angle. Here, why I am drawing this diagram? Because I want to apply loop closure equation here. This is your real axis. And this is your imaginary axis. You have to draw this diagram, all of you. So what I shown here, I shown real axis, imaginary axis, angles, and the rotations for crank and radius. R, L, theta 2, theta 3. Okay. Now I have to apply loop closure equation. So in order to draw a loop closure equation properly, we have to show arrows. So let's say it is first A, this one is B, and this one is C. In your syllabus, only 4-bar chain and slider crank mechanism is there. So we are taking numericals on same mechanisms. So how I write loop closure equation here, please? The first vector is AB. You can see this arrow direction. I'm going in a particular order. So AB, then BC, and then it is CA. So this is your sequence I consider here. I can write it as first step in solving numerical by complex algebra is write a loop closure equation. So first one is loop closure equation, vector AB plus vector BC plus, yes, what it is? Yes, everyone.
Vector CA.
CA.
It is AC or CA?
CA.
AB
CA,
plus
sir.
BC plus CA. Yes. Just proceed in a order is equal to 0. So first step is apply loop closure equation. Now tell me vector AB plus BC plus CA is equal to 0. In order to get, let's say consider this CA nothing but displacement from this piston from this reference position. Let's say it is X. So if I consider from this A to C, it is X. So get proper. If I consider CA, it will be opposite. So what I consider here, I just simplify this as AB plus BC. Now why I am simplifying, you will get idea later on. AB plus BC is equal to minus CA I am writing because I am just transferring the CA to this side. Now tell me, instead of minus CA, can I write it is equal to AC? Yes or no? Is it right or wrong?
Yes.
Yes, we can write. So minus CA is nothing but AC. Now just use your complex form these vectors. How I can write vector AB in complex form? If you remember, there is any vector R, it can be written as, yes, how I can write in complex form? See, vector R is equal to R theta is your polar form. This polar form can be expressed in complex algebra as vector R is equal to, how to write? Yes, please, everyone. In complex form.
R
If
into
you
e
are,
raised to I theta.
yes, you must know this. Those who are unable to remember this means your last lecture is wasted. There is no use of last lecture. Vector R is equal to R into e raised to I theta. Understand? So how I write here now? Tell me. Just use this basic. This one I have to use. Any vector can be expressed like this in complex form. How to write fast? AB is nothing but what is notation we use for AB? It is small r. So magnitude is R
R
into
angle
E.
60. Sorry, e raised to I 60.
Okay, right. That is right. But instead of 16 or values, I can use notations for that initially. Of course, we have to put that value as 60 only.
Theta 2.
You are right. Yes, I write here theta 2. E raised to I theta 2. Because why? You see here, its magnitude is R and direction, that is theta 2 with respect to this position, reference position. So e raised to I theta 2 plus BC. How I can write for BC? Yes, all of you. How much magnitude of BC is? L into, yes, e raised to I. How much theta is for link length, particular link. Direction, theta 3.
Theta
We are
3.
taking from same coordinate, first coordinate I am taking. So e raised to I theta 3 is equal to AC I written here. AC I am writing. So how much theta? Is magnitude how much? AC how much displacement distance is? Length is x into e raised to I. How much theta is? That's theta 4. But how much exactly theta 4 is? E raised to I theta 4. That is nothing but x into e raised to I. How much theta 4 is?
0.
60.
Theta 4 I am saying. 60 is theta 2, na? What is theta basically? Angle made by that length with this reference, first coordinate. Positive
0
x.
degree. 0.
Positive x axis,
Pi.
okay. How much? Since you are saying 180. I want to find value of theta 4.
Ha, sir, because it is CA na. Okay.
Yes, you're right. You're thinking in the right direction. Now see, one more thing. If I write CA, see the difference please. If I write CA, then how much angle is 180? Because I'm moving from C to A. You can see CA is starting from here. CA. So how much this angle is? Yes, with respect to positive x, it will be 180. Yes or no?
180.
180. But when I'm writing AC, how much that angle is?
0.
0. Understand? समझते क्या?
Yes, sir.
When it is CA, it is 180. But when it is AC, then it will be 0. So in this case, what I consider here, I consider AC, na? Not CA. So how much theta is? Theta 4 is
0.
0. And if it is CA, then in this case it is minus, same actually, here it is 180. But even though it is 180 or 0, e raised to 0, how much it is? Or e raised to 180, how much it is? How much it is? E raised to 0, I into 0. 0 only.
E raised to 0.
It is not 0, it is 1. E raised to 0.
1.
Anything raised to 0.
E raised
E
to
raised to
0
0
is
is
1.
1. So it is nothing but x. Okay. See, if I take AC, then it will be x. But if I take minus CA, then if I put CA value, of course you can put it, no problem. It will be minus. Are you getting or not? Here it is. It is minus minus, again
Yes,
it will
sir.
become plus. It's minus x because e raised to minus 180. E raised to minus 180, how much? Minus 1. So minus 1 into this minus 1, it will be plus only. So no doubt whether we take minus CA or AC, we will get the same answer. Don't worry about that. Even though I put directly here also, then we'll get answer. But in order to get this proper equation, I just simplify this to AC. I think it is clear. So what is our equation now? X is equal to R into e raised to I theta 2 plus L into e raised to I theta 3. Equation number 1. Clear? How I get this?
Yes,
It's very
Yes,
simple.
sir.
Just we take loop closure equation. In loop closure equation, write in complex form and you get simplification, simplified equation. So remember, this is what application of loop closure equation. First step is loop closure equation. Consider your mechanism. Right, consider a coordinate system. Write a loop closure equation. Express that vectors which you written here in complex form and get your first equation. This is your displacement equation. Clear? Or this is your position vector. I hope it is clear. Now tell me, from this equation, now it is complex algebra. So e raised to I theta is nothing but what? Cos theta plus I sin theta. See, what to find out basically, we need to find out AP and alpha 3. Acceleration of piston and alpha 3. At the same time, we can find theta 3 as theta 3 is not known. Then we can find velocity. Once you get velocity, then we get acceleration. And then we get alpha 3. But to get alpha 3, we need to find omega 3 also. So we'll find all terms through this numerical. So first, I got displacement. That is equation for x. With the help of this, can I determine theta 3? As theta 2 is known to you, can I determine theta 3? How to determine theta 3? So remember from first part, that is from loop closure equation, we will get displacement, angular displacement, which is pending. Theta 2 is known, theta 3 I can find out. How I can find out, I am telling you. See carefully here. First one, I am writing it as x is equal to r into e raised to I theta. I can write it as cos of, yes. How I
Theta
write?
2 plus I theta.
Repeat please.
Cos theta 2 plus I sin theta 2.
Yes, it is cos of theta 2 plus I sin of theta 2. Similarly, plus L into, yes. What is this e raised to I theta 3? All of you concentrate here, please. E raised to I
Cos
theta
theta 3 plus I sin theta 3.
plus I sin of theta 3. I request you can write along with me or at least observe along with me. So that if I ask questions, you must be able to answer. Okay. So let's say we'll call it as equation number 2. And now if I observe this equation, there are some real part, there are some imaginary parts. So first term is real, second term is imaginary. First term is real, second term is imaginary. Therefore, I can also write this x in terms of real and imaginary parts. How I write here it is x plus 0i is equal to same equation. X plus 0i is equal to same equation. So I'm not writing this equation here, but it is same. Now tell me, if you want, we can take real part separate and imaginary part separate. Okay, I'm writing here. It has x plus 0i is equal to, let's write real part and separate real and imaginary part. So which one is real part of this term? R cos theta 2 plus, which one is real part here? L cos theta 3. This is your real part. And imaginary part is R, I'm writing R sin theta 2 plus L sin theta 3 into I. So this is your real part, this is your imaginary part. Here also on left hand side also real part, imaginary part. If I equate this, then what you get? Just observe. If you equate this, so tell me what is your real part? If I equating real and imaginary part. So x is equal to, if I equating real part, nothing but x is equal to r of cos theta 2 plus L cos of theta 3. Let's say call it as equation A, real part. Equating real part, we get equation A. Equating imaginary part, it is 0. So 0 is equal to I, means we are equating this I and this I. So it is 0 is equal to R sine of theta 2 plus L sine of theta 3. Equation number B. Clear how we get A and B? Hello?
Yes,
Is
sir.
it clear how we get A and B, what we did here? Very simple. What we did here is, I just equate real and imaginary part. And if you solve these two equations, here it is 0. So just put values. Theta 2 is known, R is known, L is known. What is unknown here? All of you. Unknown. Equation B, unknown is what?
Theta 3.
Theta 3. So find that. So put values here. So R is 0.1. You can observe R is 0.1 because 100 mm, 500 mm, theta to 60. So 0.1 meter. Here it is 0.5. So put these values R, L and theta 2. All of you solve this. 0.1 into sine of theta 2. Sine of theta 2 is 60 degree. You can put values here. L is 0.5 into sine of theta 3. So find theta 3 is equal to 0. Tell me answer. Theta 3 is equal to. Everyone please. Find out theta 3 fast. Just you have to solve this equation.
Minus
360.03
9.97.
Yes, sir.
Minus 9.97.
Okay, all of you write your answers in chat box, comment box. Yes, it is minus 9.962. But when I said minus 9.962 degree, can I write it is equal to how much? Not approximately, but I'm saying exactly it is equal to. Can I write like this? 350 point
038.
Understand? It is plus. So we find out theta 3. Now, okay. Next one is to find out angular velocity of connecting rod. Means I find out theta 3. So second task is to find out angular velocity. To find out angular velocity of connecting rod. Okay, so what to do here now? Velocity of piston is equal to S. How to find out velocity of piston? D by dt of basic equation, d by dt of x. What is your equation of x? D by dt is of x is what? You have this equation r cos theta 2 plus L sin L cos theta 3. Or you can say, instead of cos I am writing here, basic equation, x is what? Here it is. X is what? R into e raised to I theta 2 plus L into e raised to I theta 2. So, theta 3. So just use that. That is d by dt of R into e raised to I theta 2 plus L into e raised to I theta 3. Okay. Now again, I have to write. So we have to differentiate here. So velocity of piston is equal to, how the equation is, R is constant. This I into e raised to I theta 2 into derivative of theta 2 is omega 2 plus derivative of this L constant into I as it is e raised to I theta 3 into derivative of theta 3 is omega 3. Just simple derivative. That is your equation number 3 I am saying. Now again, what to do here? Just simplify real part and imaginary part. And for getting real part, imaginary part, I have to write R this omega 2 into I e raised to I theta 2. So it is I into e raised to I theta 2 is cos of theta 2 plus I sin theta 2. Just put these values. I sin theta 2 plus L omega 3 into I into e raised to I theta 3 is cos theta 3 plus I sin theta 3. Okay. And now let's say it is equation number 4. Just I'm saying I'm saying separate real and imaginary parts. So what we can do here is, if I separate out this, it is R omega 2 into cos theta 2 plus L omega 3 into cos theta 3. That is your, I'm writing here, it is cos theta 3 into I. You can see R omega 2 into cos theta 2 into I plus L omega 3 into cos theta 3. This is nothing but imaginary part into I. And this I into I, it is minus I square. And I square is minus 1. If I simplify this, means if I multiply inside, it is I part. But if I multiply to second term, it is I into I is I square. I square is minus, so it will become real part with negative value. Similarly here also, this imaginary part, but this inside is I into I is I square, it is minus 1. So it becomes imaginary, real part with minus value. So it is, I am saying, minus R omega 2 sin theta 2 plus, here it is, L omega 3 into sin theta 3. Of course, you need to do this on your own. Then only you understand. It's very simple actually. So I just separate out real and imaginary part. Then as per your procedure, what to do here? Just write real and imaginary part separately. So what I write here now, velocity of piston is equal to Vp plus 0I. So real part is Vp. So Vp is equal to this. That is minus R omega 2 into sin theta 2 plus L omega 3 into sin theta 3. Equation again, let's say C and D. C and this imaginary part equal to 0. That is 0 is equal to R omega 2 cos theta 2 plus L omega 3 cos theta 3 is equal to 0. If I, that is equation D, solve C and D, or just put value of, get value of D equation. What you obtain from this one is, what you get from this? What you can find out from this equation? Omega 2 is known, R is known, L is known, we get omega 3. And once we get omega 3, we can put in equation C to get value of Vp. So find out omega 3 and Vp from these two equations separately. From this equation D, get value of omega 3, angular velocity 3. Just put in equation C to get omega, that is Vp. Tell me answers. Anyone? Okay, we try this one. The answer is omega 3. Yes, anyone? It is minus 1.5229. As it is omega, it is radian per seconds. But minus, so we can write it as minus means it is clockwise. So I can write it is equal to 1.522 clockwise. Actually, this one is anti-clockwise. And Vp is equal to 0.39114 meter per seconds. Like this you can solve. Minus 1.523. Yes, it is. Right, it is. But it is minus means it is anti-clockwise. If I write plus, it will be clockwise. You are right. Sagar, Mrunal, both of you are right. Okay. Now see, what we find out up to here, it is only Vp and omega 3. What we did, you can understand, I just differentiate equation of x to get velocity. Further, if I differentiate this equation of velocity, what you obtain? All of you, just we need to end. If I differentiate equation of velocity, what you obtain?
Alpha. Acceleration.
Acceleration. Okay. Now it will take time, as the there is limited time for this lecture. Maybe second lecture started as per timetable. I'll just show you. You can see acceleration. How to find out acceleration here now? So up to here you solve, that is Vp is equal to 0.39 something. But in order to find acceleration, what to do? Just differentiate this velocity equation in the same way. Now which velocity equation? That is in the complex form. Just differentiate that, separate out real and imaginary part, and equate to, we get two equations like this. We get acceleration is equal to this, and the imaginary part is equal to 0. So by equating real and imaginary part, we get these two equations. So this is your equation, let's say E, and this is your equation F. Now E, if I find out this from this equation, as in this equation omega 2, theta 3, all are known terms, we get acceleration first. Acceleration of piston. And if I find out that other values here, we get alpha 3, means theta 3, theta 2, then omega 2, omega 3, all are known to you. If you put it here, we get value of alpha 3. So likewise, only two terms are remaining, that is AP and alpha 3. I request you, just differentiate your velocity equation to get acceleration as well as alpha 3. So I'm writing here. After this, what to do is, the next step is to find out, third step, to calculate acceleration parts. So to get AP, just differentiate velocity of piston equation. Then separate real and imaginary part. One equation will give you AP, other equation will give you alpha 3. So get these values. In next lecture, I will ask you this. You have to complete this. This is one example based on a complex algebra method to solve a kinematic analysis problems. Why it is kinematic analysis? You come to know that we are finding velocity and acceleration with known dimensions. Is it clear to all?
Yes.
This
Yes.
numerical concept is clear?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Now you do one thing. You have to solve these two things at the same time. You can solve. I'm saying you can solve a 4-bar mechanism problem. At least try it. I will share that problem on Google Classroom. So on the Google Classroom, as a first assignment, you need to complete this numerical based on 4-bar chain, and this numerical also you have to upload. So today you have to upload 2 numericals. One we discussed today now currently, and second one I will upload. Statement I will upload for second numerical. Once you solve it, you have to upload on a Google Classroom of KOM subject. First numerical already given to you. Second I will upload. Here you need to solution. You have to upload solution of first numerical. In a single PDF you can write. That is first numerical, its solution. Second numerical, its solution. Upload to KOM Classroom. Okay.
Yes.
Sir, will you please share the photos of these papers?
Okay. I will share my notes photos.
Okay, sir.
Okay. I will share already all the notes are there. So I will write written notes photos to you instead of this. Any other doubt?
So we are
Yes, any
solving
doubt?
this
Yes,
by
please.
a complex method, no? We are solving this. Can we solve this by vector method also or not?
Yes. That's what last part is. These are the different methods we are discussing. Like first one we discuss analytical method. Now we are discussing complex algebra, and after this we are going for a vector algebra. Same numerical you will solve by different methods. You must get same answers.
Okay, sir.
These are the alternative methods. Okay, and each method is having own advantage. Clear?
Yes, sir.
At the end, when we discuss all methods, then we'll see how we can compare and all. Okay.
Yes.
Next method we'll discuss in next lecture.